This talk is brought to you by the Bamberg Mathematical Consciousness Science Initiative.
Thank you very much, and good morning, everyone. Welcome to today's talk, which might be a controlled hallucination we are all experiencing, at least if we follow Anil's definition of reality. And indeed, the line between controlled hallucination, illusion, and the so-called veridical perception can be indeed very narrow. So in the context of the present talk, I will elaborate on illusion, and I will use the term illusion to refer to perceiving a stimulus without its corresponding presentation of that stimulus. So it's about illusion paradigms in the search for neural correlates of consciousness. The goal is to give insights into why and how illusion-based paradigms might be useful to give us really a unique window into consciousness and the neural correlates of consciousness, the minimal neural events and mechanisms necessary to give rise to specific conscious experience are today in this talk placed in this temporal context. And I think it's quite fair to say that studying NCC can mean studying somewhat fragile phenomena and creating or eliciting illusions under lab condition can be somewhat fragile phenomena too. So why combining the two? And what is this talk really about? I will address the question of whether illusion paradigms are valuable for NCC research. Does it even make sense to compare veridical perception and illusory perception? Are there meaningful, neurally similar signatures, for example? And what can we find so far in this very small literature body? Also, I will have a short look on are there any correlation between pre-stimulus, or in our case, pre-non-stimulus brain states in correlation to the perception of an illusion. And in the last part of the talk, I will talk more about the concrete paradigms, just to give an example on how this could look like concretely in the lab. And also we will see then that there unique challenges that come along with that kind of approach. And to understand the motivation behind studying NCC from the perspective of illusory perception better, we have a look on classical NCC candidates. For example, the visual awareness negativity we heard about yesterday also is today widely considered as a possible marker of conscious perceptions. Also with analogous negative deflection in the auditory and sensomotory modalities, the AAN and SAN. And sometimes, as we heard, they are collectively referred to as the PAN, the perceptual awareness negativity. Now, how were these markers determined? The majority of these studies use paradigms where they rely on the comparison between hits versus misses. But when physical stimulation is nominally identical, even if we make sure of that, these paradigms still allow for subtle variations in stimulus strengths, just in general, various stimulus biases. And I'm not saying that in illusion paradigms, we don't have any stimulus-driven effects, but in general, the idea is that using illusion paradigms helps decoupling those stimulus-driven factors and external factors from the actually subjective experienced conscious percept. So illusion-based paradigm offer this unique opportunity to take an NCC candidate that we already found in the literature and test it. And that is the idea that we had. So we asked ourselves, do illusory percepts also elicit a van? Because again, in this case, an illusion is the perception of a stimulus that is absent, and if van truly reflects subjective consciousness, it should also be seen and shown in an illusory conscious perception. Oh, sorry. However, testing the van using illusory perception can, as I said, only work if we assume that illusory and veridical perception are neurally at least very much comparable. And there is substantial evidence suggesting that assumptions that show activation pattern in the primary visual cortex, they overlap between illusory and veridical perception, decoding and fMRI, MEG show similar activation pattern in superficial layers of the V1, for example. So studies are suggesting that there are very similar neural activation from very early on. This is also shown in EEG. These kind of studies were more exploratory, so they didn't necessarily use a van-specific analysis. But here again, we see that, for example, the perception of an illusory flash or a really presented flash had very similar ERP components. But there's also literature that shows that when you ask participants afterwards, they can distinguish having seen a real flash versus having seen an illusion flash. So overall, for now, we can assume that these are neurally sufficiently similar also for our question and for us to use the illusion as a vehicle to study NCC, although they're for sure not identical. For the question if illusory percepts also elicit a van, we used a bimodal design, the so-called sound-induced flash illusion. You see the 4 experimental conditions here. Actually, these were 8 because stimuli were either presented in the upper or lower visual field. We always presented 1 or 2 very brief 17 millisecond flashes. And in half of the trials, these were paired with 2 very short 10 millisecond beeps. Now, the critical condition here is marked in green. Pairing a single flash with 2 beeps can lead to the perception of a second illusory flash. And this is why it's called the sound-induced flash illusion. And after each trial, participants then rated their subjective impression on a scale from 1 to 4, 1 indicating having seen no flash and no second flash, and 4 indicating a very clear percept of that second flash. As expected, when 1 flash is presented without any sound, participants usually report seeing only 1. When 2 are presented, whether with or without tones, they often report 2. So first of all, this shows us that they seem to pay attention. They are able to distinguish the perception between 1 and 2 flashes, and they're using the scale in a reliable way. And now what's critical again is marked in this green box. Here we see the typical sci-fi as sound-induced flash illusion pattern. About 50% of trials are reported as containing a second flash, even though only 1 was shown. And so now for the sake of time, I will focus only on this condition and this analysis, and here also only on that part where we specifically dichotomized illusion versus no illusion or seen versus unseen. One comment to better understand the next slide, because we conducted a cluster-based permutation analysis restricted to the expected van search space and also temporal interval, so posterior electrodes and a range of 100 to 300 milliseconds after stimulus is normally that search interval. However, since our relevant stimulus, and I will elaborate more on this later on, here is the anchor of the second beep. That's when we assume the illusion. So we also had to shift our search interval to 180 to 380 milliseconds. And that's exactly what we found, a significant difference between seen and unseen trials with a negativity in the expected time window. For those who work a lot with Venn paradigms and are familiar to the topographers, you will notice that we have a more period-to-central maximum. And not all Venn studies actually always report their topographies in the first place, but those they do often show a more occipital-temporal maximum. And I found actually more and more variability, and these can also be partly explained by differences in processing level, for example. So in our case, we might be capturing a more low-level processing of a very simple stimulus like a super brief flash, rather than a high-level awareness involved in other paradigms where houses or faces or more complex stimuli are perceived. And that may partly, at least partly, account for the topographical pattern in our data. There's a quite similar study using the HiFi, or the touch-induced flash illusion paradigm, and they found an occipital difference in the Venn time window. Also, again, distinguishing illusion from no illusion trials, indicating Venn-like spatial and temporal properties. So very similar to our results. But what if we leave the visual modality? If we can find an illusory Venn, can we also find an AAN in the context of illusory perception? And to my knowledge, only few studies have directly examined ERPs elicited by consciously perceived but physically absent auditory stimuli. But they found negative deflection were more pronounced for illusory percepts, consistent with the idea of the AAN. And one group also observed later a positivity for illusory percepts also, and they interpreted this as a centroparietal positivity and suggested a decision-related or higher level, higher order cognitive processing involved here. So our first summary is, yes, we find a Venn, we find an AAN even in the absence of objective simulation, providing further evidence or further hints that the perceptual awareness negativity might actually reflect conscious perception. And altogether, these results also support the idea that we can use these illusion paradigms as a vehicle for testing NCC candidates. I have mentioned the pre-conscious processing, and I owe you another result that we had found in our sci-fi study. Alpha oscillation were more was negatively associated with the occurrence of an illusion. The more alpha, the less likely a participant perceived an illusion in that trial. Other studies also show that specific pre-stimulus states, such as lower individual alpha frequency, higher alpha power, reduced beta and gamma activity, can be associated with decreased likelihood of perceiving an illusion. And in addition to that, also particular alpha phase alignments before stimulus onset seem to impact illusion susceptibility. So we suggest that alpha oscillation may index the cortical conditions underlying the excess of perceptual content to our conscious perception. And that alpha oscillation modulate whether something gains access to our consciousness or not. So I've talked about various illusion studies, what they found, and now I think it's time to have a closer look on the paradigms that they are using, because these, as I said, also come along with unique challenges. One is to elicit an illusion systematically, because we need, of course, a good enough illusion rate to really compare illusion signatures, for example, for our ERP analyze. In classical hits versus miss comparison, we benefit from a very key advantage because the onset of the actually presented stimulus gives us a very good point, a reference point to closely then approximate or infer the onset of the conscious percept. But when we are examining illusory percepts, this becomes much more difficult. So the main challenge is that we lack of this physical stimulus to really determine the onset of the illusory percept. So there are lots of illusions, for example, like here that work very well, distorted sizes, shapes, luminance, and these kind of illusion examples will probably not so much be informative for our NCC question and the question about when does conscious perception start. Another challenge, which I find more and more in literature, but also during piloting, which makes piloting very interesting, is the high variability. So one paradigm could work very well in one participant, but then not at all. You cannot elicit the illusion with the same paradigm in the next 5, for example. So how to really build paradigms that elicit illusion robustly? Again, then not all the time, because we still need illusion versus no illusion comparison. Paradigms where we can infer the onset from and that are informative for us about NCC. And the short answer is, I don't really know, but I'm very, very happy to share everything that I've learned so far. And as I said at the beginning, the line between illusion and veridical perception can be very narrow. And one helpful framework and orientation can be the idea of a Bayesian brain. Because within this framework, conscious perception is not a direct reflection of the physical world, but more the brain's probabilistic best guess based on sensory evidence and the weighting to its internal priors and expectations. So from this perspective, an illusion defines a perceptual inference that deviates from physical stimuli and external evidence, typically because prior knowledge or very unreliable external evidence gets a new weighting. So with this Bayesian framework, we can identify 2 main approaches that systematically can elicit illusion. And one category is those paradigms that use the trick of multisensory integration. And the other paradigm is, so to speak, illusion by expectation, setting very strong priors through conditioning. And both can be implemented or understood in this Bayesian inference framework. Let's have a closer look on that. So in the context of illusory multisensory integration, illusion occur because information from different sensory modalities is combined and then also weighted in a precision manner. And when one modality is more reliable than the other, this modality will dominate the percept. This is what we saw, for example, in the sound-induced flash illusion. And then, as I mentioned here, maybe one more thing to add here, the advantage here in the sound-induced flash illusion is not only that we have a high illusion rate, probably because we are very prone to this multisensory integration mechanism that work very well in all of us, but also this auditory second beep gives a very good anchor to later on infer the onset of our illusory flash also. And the second category, illusion by expectation, work with conditioning paradigms. And now we will have a closer look on examples on how we could create a strong prior in a lab, in an experiment, but also what are the challenges that come along with that. So we start with an example of a group who employed an auditory signal detection task, and they played a 1 second long speech snippet embedded in continuous speech-shaped noise. And at the beginning, these speech snippets appeared very frequently, also in a very short ISI, to really strengthen the prior that in this noise, there's a lot of speech. Then the gaps were longer, and an illusion in this case was that during such a gap where only noise was presented, participants heard speech. So now in such a continuous paradigm, how can an onset of an illusory percept be determined? And participants were asked to press a button as quickly as they heard speech. And later then the authors analyzed the distribution of the reaction times, also referring to the actual hits. So they had a response-locked EEG analysis, they had their average of reaction time, and it allowed them to work backward from the physical action to identify really the neural signal representing the onset of the illusory onset. But there are also ways to not have to work with a reaction time subtraction method. So here is an approach of a cross-model Pavlovian conditioning paradigm that, so to speak, trains the brain to hear what it sees. So they established an association between a visual checkerboard and a tone buried in white noise. And the experiment transitioned again from a very intensive training phase and conditioning phase to a phase where they're increasingly left out the stimuli, so to speak, increase the rate of catch trials. And here the participants were asked to report when they heard a tone, signaling their decision confidence by how long they pressed down the response button. And this study had a little bit of a different focus, also different groups included, but in the healthy control group, this worked in around 10% of cases. Similar is a Pavlovian temporal condition paradigm. And here, each trial paired a visual fixation dot with a near-threshold tone at a fixed interval. Also, to establish this strong association, and they had 20 blocks where the stimulus was always presented. And then in the sequent main experiment, they even had a rate of 75% of catch trials. So auditory stimuli were presented or omitted in a predictable time point. And this also allowed them later on to infer the onset of the illusory auditory conscious percept. The illusion rate here was around 20%. So the trick in this study was fixed temporal intervals. And maybe one more comment on this, because we tried to create, or we created the very same paradigm. And all that we changed was, instead of presenting near threshold auditory stimuli, we presented near threshold visual stimuli. And we could elicit the illusion sometimes, but lots of piloting showed that it's not working in this modality the way it worked in the other. And maybe we have time later on in the discussion to go into more detail, but at the moment I can say there seems to be a difference between modalities, whether how strongly or easily and quickly a prior can be established within a paradigm, or how easily this modality can update the prior and delete it because of the sensory evidence. One last example is an illusion paradigm with a discrimination task. They presented an auditory cue followed either by noise or by a grading that was tilted in either 45 or 135 degrees. After each trial, participants provided first a binary orientation response, saying the grading orientation was left or right, and then their perceptual confidence on a scale from 1 to 4, not regarding if they were sure about the orientation, but if they were sure that they saw a grading or only noise. And here an illusion is reporting the tilt of a grading, saying I'm quite sure that I saw one, although only noise was presented. And interestingly, the study included 2 days. So the first day was mainly conditioning, meaning, again, a high prior was established for low-level near-threshold stimuli. And this auditory cue was actually either a lower or a higher auditory beep. And the association of, I hear, for example, a lower tone, and then I only see a specific tilt of the grading was established in that day too. And then on the second day, there was the main experiment with a lot of catch trials. So most of these studies that do not use multisensory integration work with high conditioning to increase priors, near threshold stimuli to reduce the validity of the actual external sensory input. And then also every perceived illusion acts like a strengthening of that prior. At least that's the idea. But again, from a lot of piloting also with different ideas, we can see that it is not that easy to establish that prior. It is very, maybe something that the 2-day setting here allowed them also was that the participants did not perceive the difference between this is conditioning and now something feels different. And maybe then they start to wonder, am I tricked here? Also with the instructions of such paradigms, you don't want to be too obvious, but you want to somehow suggest maybe this is a very difficult discrimination task. Now in the second step, we will make it even harder for you to discriminate. So the metacognitive processes here are a very big factor of does this experiment work at the end or not. So this brings us to our second summary. Pan-like negativities can emerge in response to subjectively perceived stimuli, even in the absence of external stimulation. It challenges the interpretation of the pan as a purely stimulus-driven and strengthens more its candidacy as a NCC. And we can illustrate the illusion-based paradigms provide a unique test set for NCC, but also result in methodological challenges. But the Bayesian framework here helps us to design these paradigms and elicit illusion that are informative for NCC. I think there is much more to explore, like as I addressed a little bit the differences in modalities, much more about the oscillation factors. I did not address this here, but maybe the question about gradual versus dichotomous illusory consciousness, and just overall the question of how can we create robust paradigms? Can we make more use of world knowledge to really have the use of us already strong prior in that paradigms? And then again, this was not focus of the talk, but something I find a lot in my literature research. There's, of course, this bridge to clinical hallucinations. And I would think that these are two fields where we can learn, on one hand, if we study more of illusory NC, can understand better clinical hallucinations, but also vice versa. So these question mark beginning of a broader journey and maybe also of our discussion now. I'm very, very eager to hear your thoughts, critique, comments, and I want to thank my team, especially my supervisors and mentors. I want to thank the organizers of this incredible event and you all for your attention.